Okay, I hope you've had a chance to practice alkanes. And the more you practice organic chemistry, the more you remember all those rules and all the naming, and it feels less clunky and more fluid. A little bit like when you're learning a new language and you have to translate everything all the time. It feels clunky, but then eventually you are fluent in it. And so by the end of this unit, you will be more fluent, I promise you. So we're going to cover alkenes and alkynes today. So all the rules that we learned for alkanes are the same for alkenes and alkynes. There's just a couple new tiny additions to look at with these compounds, but everything you learned before is the same. So we still have methyl, ethyl, propyl, butyl, pentyl, hex, hept, where I'm at, oct, non, and dec. You still have all of those naming systems are still the same. Only here, I'm not going to end it in A-N-E. I'm going to end it in E-N-E or Y-N-E for the very end of that parent chain. So if it's an alkene, it'll have the general rule CnH2n. So for example, C50H100. And as soon as I see that it follows that general rule, I know it has a double bond in there. So one double bond indicates an ene, an alkene. And because I have a multiple bond, this is considered to be an unsaturated hydrocarbon. Alkynes, we're going to cover them both at the same time because they're not that different. Alk-YNE has the general formula CnH2n minus 2. So C50H98 tells me that it has a triple bond in it. And therefore this is still unsaturated because by definition an unsaturated hydrocarbon has a multiple bond in it, not all single carbon multiple bond, right? A carbon multiple bond. Okay, so let's start naming these. So I'm going to still name the longest parent chain, and I'm then going to number the chain, and then I'm going to do my branches, number 3 branches. Right? Okay, so it's still the same rules as I had for the alkanes, except for here's the little tiny things. You know that game we played about the green pathway and the black pathway, and who wins the numbering system is the carbon that hits the branch first, right? Remember that rule? Here, that rule doesn't apply. We only do that for single bonds only. So I want to be carbon 1, I want to be carbon 1. Whoever hits the branch first gets to be the numbering system. In this case, we're going to look for that multiple bond, the double bond or the triple bond. We're going to look for that. And that's going to be who gets to be carbon number 1. So it's still, I want to be carbon 1, I want to be carbon 1, but it's whoever hits the multiple bond first gets to be chosen as the numbering system. Okay, so we'll play with that. And then when you're numbering the chain, that's the numbering system. Oh, right, that's what I was talking about. But actually this one is that your parent chain has to include your double bond, even if it's not the longest, right? Even if I could go this way and get 2 more carbons in, if I have to go that way to hit my single bond, then that's the way I go. Okay, so let's have a look at these 4 examples. The first thing that I want to talk about is if you have your multiple bond and it doesn't quite stretch amongst the whole length of that line diagram, that there must be a carbon here where that multiple bond ends, and a carbon here, and a carbon here, and then of course there too. Okay, so let's find our longest parent chain. So the parent chain must include the multiple bond, and so these have to be part of my parent chain. And then I'm going to go this way, and then I have a choice here of an intersection, so I could go up, down, or right. And in each direction, I only hit 1 carbon, so it doesn't really matter what carbon I hit or like which one I do. So this is my longest parent chain here. 1, 2, 3, 4, 5 carbons long. So how do I say 5 in organic chemistry? I say pent, and I'm going to run out of space here. Hold on a minute. I say pent. Now, these have a triple bond in it, so I'm going to end it in Y-N-E to say I have a triple bond. So I have 5 carbons. They have a triple bond between 2 of them, but which ones have the triple bond? Well, carbon 1 and 2 have the triple bond. So I'm going to say pent-1-ine to say that that triple bond starts on carbon 1. Okay, remembering the numbering system is who hits the double bond first. So I hit a double bond, I haven't, so he gets to be the carbon number 1. So 1, 2, 3, 4. So these methyl groups, remember these are methyls and another methyl are on carbon 1, 2, 3, 4. So this becomes 4,4 dimethyl pent-1-ine, all one word. If I want to put it on 2 lines, I put a little dash there, just like I would if I was writing a really long word in a sentence and I had to go to the next line. You put a dash, right, to go to the next line. So it's the same idea. So 4,4 dimethyl pent-1-ine. I have 5 carbons. There's a triple bond somewhere in there. That triple bond is on carbon 1. I also have 2 charms. Those two charms, those charms are 1 carbon long and they are hooked onto carbon 4 and carbon 4. Okay, let's try this one. So remember my longest parent chain has to include my multiple bond. So this has to be part of my parent chain, that carbon. There's a carbon parent chain, another one, another one, another one, and another one. I decided to go right here instead of left to get the longest chain. 1, 2, 3, 4, 5, 6. So 6 makes hex. There's a double bond, so I'm going to end it in -ine because the double bonds are alkenes. So I'm going to end it in -ine. Where is that double bond? It's on carbon 1. So 1-ene. Carbon 1, grab another color. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6, right? So then I have a branch right there off of carbon 2. So 2-methyl hex 1-ene is the name of that molecule. Here's another one. Looks a little bit like a running man. Starfish. Jumping jacks. Okay, so this guy, multiple bond has to be included in my longest parent chain. So that has to be part of the parent chain here. Let's talk about this first guy, the top guy, I mean. The top carbon could go right or could go left for my parent chain. If I go left, I'm going to hit 2 carbons. If I go right, I'm only going to hit 1 carbon. So this is my longest parent chain so far. That one, that one, that one, that one. And then it doesn't really matter if I go this way or this way. I should probably do the same as I did in my notes because they're 2 carbons long for both sides. So 1, 2, 3, 4, 5, 6 carbons in my longest chain here. So I say hex instead of 6. I say ene instead of a double bond. And I say, who gets to be the numbering system? Let's just have a little look at that first. So I want to be carbon 1, 2, 3. Well, I want to be carbon 1, 2, 3. Oh, there's a tie. So do we go with the pink numbering system or the green numbering system? Well, it's supposed to be the one who hits the double bond first, but we've ended up at a carbon 3 both ways. So then it becomes back to the whole like branch idea, right? Like I want a branch. Oh, I want a branch. So does either one of these carbon 3s have a branch? Oh, they both have a branch. Oh my gosh. So this guy has a branch and this guy has a branch. This is a methyl branch, and this is an ethyl branch. So, pink numbering system or green numbering system? Well, I want to be a carbon, right? Like, I want to be the lowest carbon. Who hits the multiple bond first? There's a tie. Okay, who hits a branch first? There's a tie again. All right, whose branch is alphabetically lower? Same tiebreaker as we had for our alkanes. So the tiebreaker here is the ethyl is lower in the alphabet than the methyl. So because this one hit the double bond, hit a branch, and that branch is a lower alphabetical number, it gets to be the winner chicken dinner. So 1, 2, 3, 4, 5, 6 is the numbering system. So here we have 3-ene, which it would have been no matter what. And then we have 3-ethyl. 3 dash ethyl dash 4 dash methyl hex 3-ene for our name. Okay, awesome. Right, next one. Longest parent chain, 1, 2, 3, 4, 5. There are no branches here, nice and easy. So this 5, I say pent instead of 5. I see a double bond, so I say ene for that double bond. So I have 5 carbons, there's a double bond. But I have 2 double bonds. Well, how do we say 2 in organic chemistry? We say diene, just like it was dimethyl. So I have 2 double bonds. That's what that's saying. Okay, where are those double bonds? Well, they are on carbon 1, 3. Okay, so the double bond starts on carbon 1 and it starts on carbon 3. So this molecule is called pent 1,3-diene. Okay, let's do 2 more examples before we finish up. So 3-methyl-but-1-ene. How would you draw this? So I'm going to start by drawing my but. 1, 2, 3, 4. There's a double bond that starts on carbon 1. So there it is. It starts on carbon 1. And then I have a methyl branch off of carbon 3. So carbon 1, carbon 2, carbon 3. There's my methyl branch. Now I have to now plug in, I don't think you can see that double bond very well. Now I have to plug in my hydrogens. So there's going to be a hydrogen, hydrogen, hydrogen. Now you have to be a little bit careful with this because carbon can only have 4 sticks. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so only 4 sticks to carbon, so just don't be too hasty with your hydrogens. So that would be the displayed diagram. A structural diagram of this would look like this: CH2 double bond, CH, CH, CH3, CH3, like that. And then a line diagram would look like this: 1, 2, 3, 4, 1, 2, 3, 4, double bond, and off of carbon 3 I have a methyl. Okay, let's try this one now. I'm going to start again with the parent chain, just like I did here. So the parent chain is pent, 1, 2, 3, 4, 5, 2-ine. So starting on carbon 2, I have a triple bond. Then off of carbon 4, 1, 2, 3, 4, I have a methyl group, methyl group. I can't just leave all my carbons here without hydrogens. So H3, H3, 1, 2, 3, 4, so no H's, 1, 2, 3, 4, so no H's, and H3. And then the line diagram would look like this: pent, 1, 2, 3, 4, 5. Just be careful because we tend to count our strokes instead of our dots. So when you're doing a line diagram, just make sure you're counting the bend. So 1, 2, 3, 4, 5 for pent. 2-ine, so there's a triple bond starting on carbon 2, and there's a methyl off of carbon 4. 1, 2, 3, 4, so a methyl group off of carbon 4. Totally acceptable to draw it this way too, right? 1, 2, 3, 4, 5 for the pent, and triple bond starting on carbon 2, and a methyl off of 4. 1, 2, 3, 4, a methyl off of 4. So either one of those is the same because it's the same molecule. It's just standing on its head, but it's the same molecule. Okay, that's naming alkenes and alkynes. And so it takes practice. So make sure you put in the time and energy to practice them.